modify, free to redistribute. Okay, so that's open source, and clouds enable us to have open source code. Um, Clouds also enable us to collaborate. So if you are working in groups on a single repo, on a single software, with the help of clouds, you can do so. And that's what we're going to see today. So some of the most popular clouds are GitHub, which will be part of this workshop. There is Atlassian's Bitbucket. There is GitLab, and many, many more, many more. Okay. So here's a small, well, not small, here are some good differences and facts you have to be aware of. First of all, in session one, what we did, we had created a repo on our own computer, okay? But then we didn't have anything on GitHub. So the first and foremost thing we have to understand is we have what is called the local repo, which is on your computer, on our computer, and the remote repo, which would be on GitHub in our case, okay? Now, usually we do not do changes directly on the remote repo or the repo that will be on GitHub. We don't do that usually. What we do is we change things on our local repo, and then we update the remote repo through the local, right? We always make changes, we always modify, we always play around with the local repo. We usually don't touch the remote repo. So in order to do this, we have to make sure that the local repo and the remote repo are always in sync. If you change something locally on your computer, you want to make sure that that change is also there in the remote repo, right? So they have to be synced. Now, another fact is that the sync that I'm talking about, it doesn't exist automatically. We as developers have to do it manually. Every time we want to sync, we have to do it manually. This sync that I'm talking about is what's called a remote link. You're having a link between your local repo and the GitHub repo through a remote link. Once we establish this remote link, we'll be able to push data as well as pull data. And this should be obvious, right? So pushing is just sending data from local to the remote. Pulling is, getting data from the remote to your local repo. Okay. You would it would be a common sense that whenever you're working in groups, you want to first update your local repo and you start your day. So for example, as you were sleeping, dreaming about nice things, your colleague in your group might have changed some things in the remote repo. So it's on GitHub. But do you have the latest change on your computer? No. So what's the first thing you do? You wake up in the morning, brush your teeth, have your nice coffee, you sit down to code. The first thing you have to do is you have to pull. You have to pull data from the cloud, from the remote repo to your local repo. Once you have these latest changes, that's when you start working and add your own changes and so on. By the end of the day, you want to push your changes and the cycle repeats. So everyone is always updating the remote repo on GitHub. That's how collaboration happens. Okay. Some of the jargons, some of the commonly heard terms that we would come across are, for example, cloning a repo. So let's say you're on GitHub, you are going through different open source code, and you happen to like a code, right? Like, oh, this looks really nice, or you need it for your project. Again, like I said, we cannot modify anything on GitHub directly, usually. So what we're going to do is we're going to create a copy of that repo, and we are going to create that copy locally. So we will take that repo from the cloud, make a copy of it, store it locally in our computer. That's what cloning is. We clone a repo, right? We make a copy. It's just a fancy term. Sometimes we might tell each other, oh, can you please push this commit to remote? This basically means whatever changes you have done, commit those changes first, and then push those commits in the GitHub repo, in the remote repo, okay? Lastly, fetch or pull. Fetch or pull is just saying, get the latest changes from cloud and work on that. Now, okay. SSH connection, or this is SSH basically means secure shell. This is a way of authentication. So from your local device, from your computer, right? When you are trying to send or receive data from GitHub, GitHub wants to know that it's really you. There has to be a way to authenticate yourself. We'll be using SSH because thanks to GitHub, I don't know why they did this, they basically removed the password-based authentication since August 2021, it was removed. Password-based means what used to happen was you would enter your GitHub email address or username and GitHub password, and then GitHub would know, oh, you're trying to connect to GitHub, you're trying to push or pull data. That's no longer possible, so all of us have to do SSH. There's something known as personal agent that would sign your data for you. I bet this sentence really makes you feel like a boss, huh? So you have your own SSH agent. This is just a way of saying that there will be a process running on your computer in the background, and this process or this particular thing would be, so if you have taken networking course, guys, if anyone has taken networking here, basically it's creating two keys, private and public key. With the private key, you will encrypt your messages, your data, and the public key will be known to GitHub. The GitHub on its side will try to decrypt using the public key. For those of you who have not taken networking, basically, you are sort of signing your data from your local computer so that GitHub understands, oh, this sign actually belongs to you. This is really you. And this is actually your device. It's not someone else's device. Okay, so it's just authentication. I have a shortcut link for myself. Let me also share the link with you guys so you can open up the page that I want you to open. This is how we would be setting up the SSH, all right? So I'm going to share this link in the chat, okay? So why don't you guys go ahead and open up that link. Easy. Easy, guys. You're never safe. We are never safe. All right. So let me share the actual link now. All right, guys, just make sure you're on the second link. I had to do it. I'm sorry, I had to do it. Okay. So this is the page that you really want to be on. Now, the first thing that we want to do in order to set up the SSH key is the following. This line here. We would try not to copy paste because especially Windows users, guys, we might face issues whenever we copy paste. I think Linux and Mac users are safe. Whenever we copy paste, there are some invisible characters added the moment you paste. So it creates issues, basically. Let's not copy paste. And writing it is not that difficult as well, okay? We are going to basically type out this statement right here, this sentence. What this would do is it would generate the private key and the public key for you on your computer, okay? So it's called SSH keygen. There's a parameter, T. Let's name it ED25519, okay? Capital C. And then in double quotes, you would be basically inputting your GitHub email address. This is important. It has to be your GitHub email address. So please make sure that you're inputting that here. Okay. Give me a few seconds. All right. Now, whenever you create this key, it would ask you where to save the key. Just press enter. So we choose the default directory. We don't have to change anything. It will ask you, well, since I already have the key, it's asking me if I should overwrite or not. To you, I believe it would ask you to enter a key phrase or a password. So just press enter. Basically, if you're prompted to give anything more, just press enter until you see your normal command line back. Okay. Awesome. Amazing. I'll assume that most of you guys are done. So now what we want to do is let's have a very quick check that the keys are actually there. Okay. I'm going to type ls, meaning list files, -a for all kinds of files, whether visible or invisible. Then I'm going to provide the directory where I saved my SSH. So it should be something like tilde, this wavy thingy, dash, .ssh, and I'm going to press enter. This would list out everything, every file that I have in this particular folder called .ssh. Okay. And in the list, we should be able to see these two files. So .pub, this is your public key, and without the .pub, this is your private key. Okay, so these two keys must be there.